Question 2 for the AI-HL exam is here, which is identical to the question 3 from the AI-SL exam, which is here. And so the following recording is my answer to question 3 from the AI-SL exam. Question 3. The owner of a convenience store installs two security cameras represented by point C1 and C2. Both cameras point towards the center of the store's cash register, represented by the point R. The following diagram shows this information on a cross-section of the store. Cool. The cameras are positioned at a height of 3.1 meters, and the horizontal distance between the cameras is 6.4 meters. The cash register is sitting on a counter so that its center R is 1 meter above the floor. The distance from camera 1 to the center of the cash register is 2.8 meters. Okay, and all nicely shown in this diagram above. All right, okay, let's underline or highlight important information. So the fact that they're at a height of 3.1 meters is going to be helpful. The distance between the cameras is 6.4 meters. Okay. The center R or R is 1 meter above the floor. And camera 1 to the center of the cash register is 2.8 meters. All right, sweet. That will get us started. And part A is asking, determine the angle of depression from camera one to the center of the cash register and give your answer in degrees. Right, okay, so angle of depression. Now, when you're finding an angle of depression or elevation, make sure that you always take your angle from a horizontal line, all right, not a vertical line. Very easy mistake to make, but yeah, always from a horizontal line. So the way I like to foolproof this is to just draw a horizontal line on my diagram. That's where I'm going to be calculating the angle from. So we're going from C1, so I'm just going to draw a horizontal line going through C1, although that's not quite perfect, but yeah, we'll go there. Cool, and what we're trying to find is this angle in here. All right, so let's label that theta, and let's zoom in a little bit. All right, so there's a couple of ways we could go about finding theta here, but the easiest way would be to form a right angle triangle. So we'll draw a line that goes through the center R of the cash register. All right, and now we've formed a right angle triangle here. Oh, what have I done? There we go. Okay, so, and we've got the hypotenuse of this right angle triangle. That's this line here, 2.8. All right. And we don't know this side here. We could find it out, but the easiest side to find is going to be the height. It'd be this side here. Okay. Now, given that we have the height of the cameras being 3.1 and the height of the cash register being 1.0, that means the length of this line here plus 1 has to equal 3.1. They have to be the same. All right. So we can go through that and we can figure out what that's going to be. So this side is going to be 3.1 minus 1, all right, which equals 2.1. All right, and so there we have the height, or let's say the opposite side to our angle theta. All right, and so now we can go about calculating what theta is, or the size of the angle theta. All right, and what we're going to be using is SOHCAHTOA, and specifically sine, because we have the opposite side and we have the hypotenuse. So let's come down here and let's charge on. So part A. So we should be all familiar with the idea that sine theta is equal to the opposite side to theta divided by the hypotenuse, right? And so then, therefore, that's what these three dots mean. They mean therefore, okay? Theta will equal inverse sine of the opposite side divided by the hypotenuse. Cool. And there we have that. All right, so we know our opposite sides. Let's just write this in. Op was equal to 2.1 and the hypotenuse was equal to 2.8. All right, so then theta will equal the inverse sine of 2.1 over 2.8, which I believe I've actually got here. Yeah, so I've already put that in here. So inverse sine 2.1 divided by 2.8. So that gives me 48.5. Yeah, let's put this. We'll put a ... answer, which is then completely unrounded. Here we go, 0, ... And then in normal IB fashion, we'll round this to 3 significant figures, which is going to be 48.6 degrees. Okay, and there is the answer to part A. Okay, on to part B. Calculate the distance from camera 2 to the center of the cash register. All right, so there's a couple of ways we can do this. The most efficient way will be to use the cosine rule to calculate this. All right, so we can form a triangle with the length across C1 and C2, the distance between those, which we know, just given the question, which is 6.4. It's going to be the same as the distance on the floor. So that's 6.4 up here. All right, and we know that this angle in here, we calculated that was 48.6 degrees. All right, and so then now we can use, the cosine rule to calculate the length of C2. All right, I'm going to write the cosine rule down here for us. Okay, so cosine rule is C squared is equal to A squared plus B squared minus 2AB cos C. All right. So talking about the elements from this formula here, okay? So, or the rule, I should say. The sides that you name A and B don't really matter so much. It's just you need to make sure that you label C correctly. C and the angle C, okay? So if we go back up here, angle, so the only angle we know is this 48.6, right? And so that means this line, which we're going to be trying to find, the distance between C2 and R, will have to be our lowercase c, or our side C, right? It has to be opposite to the angle that we're using, right? And then now whether we call 6.4, this side 6.4 A or B, or this 2.8 A or B, doesn't really matter, okay? So we can say, this side is A, this side is B, or vice versa, right? So we've got and then our angle here, this angle here, this is going to be equal to capital C in the formula, right? So if we bring that down, so we'll write, so we're going to say that A is equal to 6.4, say B is equal to 2.8, and C is going to be equal. Now we can use this 4.86, though this is a rounded number. So I would, to avoid what some people call premature rounding, I'm going to say, why don't we use our full expression here for C, or for the angle, which is the inverse sine of 2.1 over 2.8. Now, the thing is when I use this, that means it's going to give me this full answer of 48.59, so on and so forth, all right? And it will save me from potentially making a mistake where, I round too early or use rounded answers in my working for a next question. All right, very easy mistake to do. Very easy mistake to make, yeah. So let's charge on. So we have, so C squared can equal 6.4 squared plus 2.8 squared minus 2 times 6.4 times by 2.8 times by cos of this big thing here. So we'll go sine inverse of 2.1 over 2.8. Oh, I've lost the top of my square bracket. And then, yeah, there we have it. All right, nice. So let's put this all into our calculator, and then we'll have to square root it to find C, and then that will be our answer, right? So let's go through. So I might just, oh no, we'll start again. So 6.4 squared plus 2.8 squared minus 2 times by 6.4 times by 2.8. Now I know your calculators will probably let you just sort of bring an answer carried forward, and you can just put answer. Unfortunately, this calculator is not as fancy, so I'm going to have to go somewhat the long way and go here and then say, what was that again? 2.1 divided by 2.8. Boom and boom. Cool. And so that gives me C squared being, so C squared is equal to 25.094 ... Okay, and so then we can say therefore C is going to equal the square root of this answer. All right, and then if you're familiar with your indices laws, all right, to take the square root of a number, you can just take it, put it to the power of a half or 0.5. So that's what I'm going to do here. Do 0.5, and then that gives me the answer of 5.009. So 5.009 ... And so to three significant figures, we would write 5.01 meters. And there you have the answer to part B. To part C. So here we're asked to, without further calculation, determine which camera has the largest angle of depression to the center of the cash register. Justify your response. All right. Let's stress this idea. We don't want to do any more calculations. Okay. We've got to use we've got to justify our response with, I suppose, intuition. Right. So let's go back up to our diagram here. And let's just visualize, okay, if we were to move, let's draw our horizontal line across C1 and C2, so we can sort of draw in our angles of depression. Let's say we moved C1 over to here. All right, and now we'll draw our new line from C1 to R. Okay, so what we can see, that when we move C1 closer to R, given it's at the same height, the angle of depression gets bigger. All right, and it'll be the same for C2. We put C2 closer, bring C2 here. We can visually see, what am I doing? Wrong color. Visually see that this angle in here now, all right, is greater than that angle in there. Now that one's not quite as clear, but the C1, the moving C1 closer, we can quite easily see that the angle of depression gets bigger. All right, and so that's going to be part of our justification. So if we come down here, we'll say C1 and C2 are at the same height, and C1 is closer to R, hence the larger angle of depression is from C1. All right, and there you have the answer to part C.